Yes, thank you very much for the introduction. So, yeah, let's start. A bit about me. So, this is me, and my name is Francesca. As you can probably guess by my name and my accent, I'm from Italy. And I am a data scientist at Peltarion. And what Peltarion does specifically, we develop this no-code platform to enable everybody to use AI. So with our platform, you can basically upload your data set, build a deep learning model, train it, and deploy it. And what I do in Peltarion, specifically, I work in a team which is called Peltarion Applied AI. And I work on customer projects. So the customer come to us, and I help them frame their problem and also solve their problem. And I specifically work with deep learning for computer vision and NLP. And then I also help the customer take over the project themselves, so they can then reiterate it and experiment themselves as they want. And what we are going to talk today, so we will go through the main steps of one of the latest project that me and my team worked on, and this is like a small agenda of what we will go through. So first of all, we will have a brief description of the problem, then the dataset that we received from the customer. We'll go through like very briefly the model architecture, the training, threshold tuning, then a little overview of the model performance, and then the end conclusions and next steps. So yes, so let's start with a brief description of the problem. We were working with a company, which is a Swedish startup, and their goal is to help management identify problematic areas within their company, so and suggest possible strategies to overcome them. And to identify this area, they ask directly to employees, so they can have the opinion straight from employees. So they provide a free text surveys. The problem is that employees come from different countries. So we are talking about big companies that have locations in different parts of the world. They, of course, speak different languages, and we only have one free text field. And as you can see here on the right, this was their big idea. So we provide to the employees like a free text that they can write whatever they want. And then they have this analytic platform, and they wanted to integrate our NLP solution in their analytic platform. So for example, they wanted to extract what the people were talking about. So in this example here, the person writes, "I don't like my boss," and they wanted to extract like the topic. So the person is talking about leadership. And then they wanted to conduct analytics from the model output. So they could extract insights, useful insights, like people located in UK really have problem with their management, so that they could take action to improve the situation. And if now we can get to the next slide. Okay, so this is the data set that we received. It's an example, a made-up example, but this is very similar to what we received. So as you can see, we have a free text answer. So in multiple languages, first was in English, and it's about a person that's talking about, very enthusiastically about their colleagues, because I really love my colleagues. They are the reason for me getting out of the bed in the morning. And also we have some other indications of a person writing. Of course, these surveys were anonymous. For example, a person is in UK and how much time they spent in the company. And then we have a list of topics that our customer manually annotated. And they also choose the topic that they wanted. So in this case, we have psychological safety and leadership. And as you can see, we had different languages in this data set. So a bit of an overview of a dataset is we received 2,325 samples divided in, and we had like 7 topics in total, which were set by our customers. And our dataset was in more than 20 different languages, so it was a multilingual dataset. The categories, so the topics are not exclusive, because of course a person can talk about different things in the same survey. And the dataset was imbalanced, meaning that for each labels, the amount of negative samples were much more than positive ones. As you can see on the right, there is a small graph that basically, you can see all the 7 labels: leadership, product services, business strategies, psychological safety, and so on. And the blue bar represents the amount of samples in percentage in the dataset. As you can see, the biggest one is leadership, because lots of people don't like their bosses. So, and it's less than 40%. And so the negative sample are much more than the positive ones. And then the worst one are brand and tech infrastructure, for which we had really few samples. And so our solution basically consists, first of all, we framed the problem as a multi-label classification problem, because we have one text and multiple topics. And then we fine-tuned a multilingual model on our platform. And in the end, we tuned the prediction threshold for each label. And now I can go through the last 2 points a bit more in details. So regarding the model architecture, here on the right, you can see an overview of how the model look like. So the input is, again, the text from the employee surveys. Then we have the block in the middle called sentence, XLMR, is a pre-trained model that extracts the sentence embedding, so basically maps the paragraph into a multidimensional vector. In this case, it has 762 dimensional. And then I will explain a little bit more about this model in particular. And then we add a dense layer with 7 units, because we have 7 labels. And in the end, our target is, again, 1 or more of the 7 topics. And just as specification about the sequence length of Syntax LMR, which is a transformer-based model. And we choose a rather longer sequence length, because we had very long text. So a smaller sequence length, we couldn't really capture all the topics that the person was talking about in the survey. And yes, so about sentence XMLR. So this model is a transformer-based model, and is a state-of-the-art multilingual model. That's also the reason why we choose it, because we had lots of multiple languages. And it's available on Hugging Face. And in particular, we used the sentence XMLR model trained by sentence transformers, which basically has a slightly different training method than classical XMLR. Unfortunately, you can't see the article in this slides, which is cited below. But I refer you to that article by Reims and other authors, which is about this particular training method. And the idea is that they wanted to produce higher quality embeddings for multiple languages, starting from a monolingual model. And the idea is that, as you can see on the right, you have 2 languages, to have 2 sentences in 2 different languages, which, however, are just the same sentence, one in English and one in Italian. So I have "I hate my boss" and "Odio il mio capo." And the model should map these sentences exactly in the same location of the embedding space. And this is not guaranteed with traditional XLMR or multilingual BERT. So that's the reason why we choose this. And also because it's very conveniently on Hugging Face. And regarding the training, so the model was trained on our platform, and actually we did a fine-tuning. So we used basically the best, the standard practices for fine-tuning a test classification model. We used a slanted triangular learning rate schedule that you can see here on the right, representation of a learning rate. Basically, how it works, so the learning rate increases for what is called warm-up epoch, which is in this picture here is 0.5. So it peaks after 0.5 epoch linearly, and then decreases linearly after this warm-up epoch. And the idea is that we wanted first to converge faster in the parameter space and then refine the parameters later on. Of course, we trained for only 2 epochs because we want to avoid catastrophic forgetting, and the training time took approximately 20 minutes for all the different for all the different experiments. Yes, and regarding the threshold tuning, so we did an additional we use an additional technique to improve the performance. And so first of all, what I mean with threshold tuning, who don't know this particular technique, so here in this image below, you see like an input example, which is I love my colleague. And here you see basically the model output only for the label leadership. So you can imagine that we have like 7 of this, but here I just show leadership. And as you can see, the model output for this label is 0.3. And then we have a threshold, which is the red line in the middle of this gray bar, which is the prediction threshold. So basically, if the model output is below the prediction threshold, you predict leadership as 0, otherwise you predict it as 1. And so we looked around, and in particular, we found inspiration by this article by Alo Taibid and Ali. It's about like a comprehensive study about different ways for threshold tuning for multi-label classification model. And so, in general, the threshold can be considered an hyperparameter, and you can tune them to achieve even better performance. So here is what we did specifically, and basically we set an individual threshold for each label. So each label had a different value for the prediction threshold, and also how we choose this threshold was to optimize to have the best F1 score for that specific label on the validation set. So we choose the threshold that basically let us have the best F1 score on the validation set, only considering the model output on for that label. And yeah, we choose the F1 score basically because we didn't want to, we didn't have a preference for positive or for negatives. And also, as you see before, for each label, we have much more negative samples than the negative. And now on the right, you can see the final threshold values, which are in a very strange format here, but as you can see, they are basically different for each label, and yeah, basically almost all of them are below 0.5. And now we get a bit of a view of the model performance. So these are the performance on the test set per label, and in the end you can see the macro average and micro average for F1 score precision and recall. The best 2 labels were product services and leadership, which were also the most represented in the dataset. And the worst one was brand, not only because we had very little sample for brand, but also because the definition of these categories was very fluffy. So it was really like hard both for the people that annotated the data and also for the model to pick up patterns that refer to brand. And this is an example on how the model worked in the end. So you have a sample here, which is a made-up sample, which is about a person that writes that they do not like the direction that the company has taken, and they want employees to be heard and taken seriously. And on the right, you see the model outputs, just the highest 4. So the blue bars, basically, it's the model output for each of these 4 labels. It varies between 0 and 1. And the red line is the prediction threshold. And as you can see, it's a different value of the threshold for all the labels. And so you see, in this case, the model predicts the leadership and psychological safety. So to conclude, which were the main challenges in this project? And I would say they were related more to like the communication part than really in the data science part, because first of all, we spent a lot of time with knowledge sharing. because the customer from their side, they don't have a data science team, but they are also the domain expert. So we spend a lot of time trying to explain to them like our reasoning and our technical results in a way that they could understand, and also we really spend a lot of time trying to really understand what they wanted to achieve with this project. And I think honestly it was time well spent. But of course we spent like lots of hours discussing and so on. Second challenge was the time. We had really a tight schedule because our customer was working with our company. So basically they had stakeholders themselves. And so both of us were on a really tight schedule, and every iteration of this project was, we really had, we lacked time a little bit. And in the end, I would say manage expectation, but mostly from my side, because I was very focused in trying to achieve the best performance possible for the model. And but sometimes sometimes it's not possible really to do better than what you're doing because of lack of time, because of infrastructures, or because of data quality. But what was really important in the end is to see the reaction of our customers. I had the chance to see our model integrated in their analytics platform, and see how how amazed they was about about how everything was working in the end. And since we spent so much time in explaining them, for example, which label were working best, which label were working less good, they managed to find a way to work around the flows of a model. Because really, I think that, again, the time that we invested in learning together what the problem was, and and to teach them how this model works was really worth spent in the end. And to conclude, so we provided them an API to call the model in inference and the values of the label thresholds, and they integrated it in their in their platform. And so we are now working on expanding this project actually, and these are the next step for now. So first of all, we want to try to do some unsupervised topic modeling, because again, as I told you before, these labels are chosen by the customer, but of course that it's based only on the domain expertise mainly. So we want to try to give them like a support for their decision making. And then we want to incorporate sentiment analysis, so not only knowing what people are talking about, but also how people are talking about things. And since we thought about doing aspect-based sentiment analysis, but right now we don't have the annotations for this kind of problem, so we'll see what we can do about it. And then, of course, we want to be mindful about bias, because we are talking about just different countries and different languages, different demographics, and we want to, first of all, detect if the model is biased and mitigate the bias when possible. And in the end, again, continues with the handover of this project. So help the customer really become independent and take this project and do, whatever they want, with limited support from our side. Yes, so I thank you, and yes, let me know if there are questions.
Thank you. Thank you, Francesca.
Thank you.
Really great to hear these concrete examples from the real world of implementing AI.
And we already have the first question.
I guess it's a pretty quick question. But going back to your model, you had after the transformer, you had a dense layer and a softmax. It wasn't mentioned, but what was the output?
It's a sigmoid, actually,
Sigmoid.
because
Okay.
the output is actually a vector with it's 7 dimensions, like with 7 nodes, because one for each label, basically. So it's a sigmoid activation.
Yeah, that would be my question then. Was if it was a softmax, how would that relate to the adaptive threshold? Because I guess if you have a lot of sentences where you have lots of classes in the same answer, I guess the softmax would not work very well with adaptive threshold, because I guess all of them would be pushed towards 0.
Yeah, basically you would choose only the one with the biggest output. But here you can imagine it like a 7 binary classification problem. So each label is basically one binary classification problem. Yes, we have leadership, or no, we don't. And this for each label. So yeah, that's the reason why you can actually move the thresholds.
Great, thanks. Do we have more questions? Yes, I'm coming.
Thanks for the talk. I'm interested in how is this running today on the customer's end? Do you just provide them with a black box that they run on their end, or are they calling a service that is running on your side, on Peltarion's side, or how is that deployed?
Yes, so basically our platform is a cloud-based platform. So yes, we provide them an API and we run it on our environment basically. And in their platform, they just call the API, and the input is the text, and the output is a dictionary with all the outputs, the model outputs. So like the 7 labels and the model outputs. Yeah.
So when you talk about handover, you're basically talking about a world where this is no longer running in your environment. You've just the customers on their own, essentially.
No, in this case specifically, it will keep running on our environment. The fact that, for example, since they work with different companies, they will have a different set of labels. And what we want to do is we have this platform that enables them to retrain the model without actually having a data science team, because it's a no-code platform. So in this case, when I talk about handover, I mean letting them, like giving them all the necessary information about how to annotate data and how to choose like labels so that they actually guarantee good performance, and how to train a model on our platform and so on, so they can actually reiterate the project themselves. We give them like a little bit of help, but the idea is that they actually like own it, but it will still run on our environment.
I see. Thanks.
Thanks for a great presentation. I'm wondering, how do they use the labels after you provide them? Like, what is the business case of it?
In what do you mean precisely? How do they use the label? So.
Yeah, because they provide with the free text and they get the labels. But what happens after that, after they get the labels?
So I can probably go back. Maybe I can go back. I can slowly go back, and meanwhile I go back, I can tell you that so they have a lot of experience in helping companies in improving their management. So they already knows what, they already have an idea of what to investigate for. But for example, leadership is one of the topic that they choose, because leadership is often a problematic area. So their reasoning right now is based mostly on their experience, but the idea is that, as you can see, like here on the right, when they basically extract the topics from the model, and so you can imagine that you have, for example, you're working with a company which has, I don't know, 40,000 employees in the world, and you get 40,000 surveys, and then you use our model to basically extract what people are talking about. And then they use their analytics platform to basically, for example, see, okay, people in South America talk a lot about leadership and psychological safety. People in this other part of the world talk a lot about business strategies. And so based on that, they can look into some specific example and really like understand what the problem is in the company from what the employees write. And then they can go to the management, they work with the management of that company and tell them, hey, this is like a problematic area, this is the solution that we propose to solve it. So I hope this answers your question.
Yeah, it's kind of an overview that you provide. And then
Yes, yes. Basically would be impossible to just read 40,000 surveys. So in this way, you can at least have an idea of what people are talking about, and then go deeper later.
Thanks.
I think there was one more. Yeah.
Thank you for the talk. Somewhat connecting to with an earlier question, since you're working with free texts from the client that could potentially, say, contain sensitive information, how do you at Peltarion work with data privacy and GDPR concerns?
So this is a very good question. So we are GDPR compliant, and we are working a lot on that lately. Also, we are very working a lot internally about privacy, like security, and in particular, we do have like an internal team that specifically work on deep ethics. Here in this case, we actually don't have particular problems in like particular concerns, mostly because our customer takes care of this part in this particular case. But of course, like it's an open question, so we are still like investigating as a company in the best ways to avoid these kind of problems.
Thank you.
Hi, my name is Henrik Rodin, representing A3 Future Tech, and I have a follow-up question on what was just asked regarding GDPR and sort of safety or personal information. I mean, what if there's a country where there's very few employees? You risk actually isolating them and being able to identify them based on the language or based on the country. I mean, if that's one of the classifiers or how you segregate the data. So if you say, what did people in China, or maybe that's a bad example, I don't know, but some small country, Switzerland, think, and it turns out that there's only 2 people who replied to the survey from there. How do you handle that that data, the fact that you could, in principle, identify who it is that answered the theory, Yeah.
So first of all, we actually do not have our customer do not work with small companies simply because you really don't need an NLP model if you have like 10 surveys. You can just read through them. So that already makes really hard to like understand, like to trace a person. But honestly, they are really, let's say, in this particular case, they are taking care about this problem specifically. So I don't have an answer by our part because we have this extra layer that that our customer basically provides to the company. So in this case, like we just made sure that that basically what we were going to investigate is that the model is not biased, for example. But in that regard, is not something that we are considering, simply because our customer, which is working in this field, is doing that for us.
Right. Thank you.
Thank you very
for
much.
a great talk.
Thank you.